Good morning, everyone. I'm Alexis Lau of Hong Kong University of Science and Technology. Thanks very much for attending the forum on, actually, this is to report and really about a workshop we just held in the past few days on this topic called Convection Permitting Climate Modeling Workshop. Why we have this so funny name is that actually a lot of climate research use model to predict the result. But a lot of the model, because the model has to cover the whole world, the resolution is quite coarse. Like typically maybe used to be 100 kilometer per grid. Now we have high resolution global model, maybe 10, 20 kilometer per grid. But clouds, which are a very important driver of rainfall, are actually much smaller than that scale. So a lot of time we were not able to stimulate the physics of clouds and convection. And it has always been a challenge to do that. And this is particularly difficult in the tropical area where we have very small convections. And there has been a group in the maybe past 15 years really trying to address this issue with very high resolution model down to a few kilometer or even now down to a few hundred meter, trying to dynamically stimulate the cloud so that all the physics associated with that can be understood or stimulated by the model. Okay, so why we have to have convection permitting model is because we really need these understanding. And this is most important if we want to get the rain right, because well, clouds are the driver of rain. If we can't stimulate cloud, we can only parameterize what we have in rain. So this is the 9th CPCM workshop. And actually, it's the first time. It started, I think, the first 2 years at Boulder, Colorado, at the site of the National Center for Atmospheric Research in the US. And after that, it has gone to South America, gone to Europe, and I think there is 2 online during the COVID in Japan. But first time face-to-face coming to Hong Kong, coming to Asia. And actually we talked about this last year about whether Hong Kong should be a good place, what is the time, and somehow we decide to have it on the 5th to 7th of August. Yeah, so we make a projection, not prediction. Okay, so I think a lot of the team members come, and I asked them, a lot of them come on Saturday or Sunday, so they have seen some extreme precipitation. But just show you the team. This is actually the first day of the meeting on the 5th. We cannot meet physically, so we don't have a picture. This is a picture taken after the finishing of the second day. But you can see from here, we have really experts from 13 countries other than in China and Hong Kong. And actually, most of them are from either the National Weather Service or the leading research center in this country, looking at really the rainfall as well as the climate problem. Okay, I think what is different between this group and the other climate groups is that these are really model developer, because to simulate this type of physical phenomena, we need to have the physics, the land surface, the coastal land-sea interaction, all these things in the model, and it takes a big effort. Each of this group probably have over 50 people in each of this group, and they have representative here. So they actually represent, I would say, all the major urban model developer in the world, and talking about, okay, if we want to get this right, this is really what are the needed things that we need to do. So in terms of focus, we talk about, well, assessing current capacity and gaps. We saw that, well, by knowing how much we can predict Tuesday's rainstorm, there's still a lot of gaps. And then looking at whether how high resolution modeling, as well as in particular in recent years, AI, can combine to do better. And then it's very important for us to say, okay, next few years, what is the research direction? Because time is very tight. And extreme weather events are really coming up here and there everywhere. So what is the research direction in the next few years that we have to focus on? Okay, so that's really a lot of experts here. And well, we forget to invite one very important participant. So the participant come over itself, okay? Our first day of the meeting is on the 5th of August. From 9 to, actually, our registration start at 8:30. This is the Hong Kong HKUST radar map. So extreme precipitation decided to join. So we have a black rainstorm warning all day. And actually, we were a little bit caught, and we were always hoping. We think that face-to-face meeting is very important. That's why we decided that we should try to do face-to-face. But eventually, we have to revert to do the first day online. But I think thanks to modern technology, we will eventually starting the online meeting at 2 and then actually finish at 5. And by that time, our guest participant decide, okay, enough, heard enough. Okay, but anyway, this is really a very good demonstration to a lot of our visitors from different parts of the world. Actually, extreme rainfall definition is different in different parts of the world. We heard some very interesting description. In some of the Northern Europe, they are looking at historical extreme is 58 millimeter per hour. But the other thing that really impressed our participant is how well Hong Kong coped with this event. And that is actually, I think this particular case has shown to our international visitor Hong Kong's resilience. And I think in the, so here we have this panel. Today we report what we have talked about, and we will have 2 panels. First one, we have trying to understand the challenge. And then the second one, really how different cities cope with the extreme rain, okay? So without further ado, I would invite Professor C.M. Sum to help moderate the first panel, which is more a reporting of the challenges and scientific understanding. So, C.M.
Good morning, everybody. Thank you, Alexis. So without further ado, I'd like to introduce our 2 panelists. First is Dr. Andreas Prein from the ETH Zurich, and also our local expert, Dr. Chen Faye from the Hong Kong USD. Maybe please take a seat. And then and they will each provide a 10-minute summary of what transpires from the workshop in the past 3 days. So may I invite Andy to do this first, and then after that we will have our panel discussion.
Good morning, everybody, and it's a big honor to be here. Thank you for coming. was actually really exciting to be here this week. This is the satellite image of Tuesday, and you can see how the clouds formed, and this was really a larger scale system, and it's actually exactly these kind of storms that cause major problems in this area and other areas around the globe. So I wanted to give you a few key messages right away, just to clear the room. Like, extreme rainfall is increasing everywhere in the globe, and Hong Kong is not an example in Southeast Asia. And this is due to the accumulation of greenhouse gases in the atmosphere, and this will continue into the future. So we are in the middle of it, and will probably intensify. So we have to be prepared. It seems like the rarest events are intensifying faster. So the ones that have the highest impacts are getting especially stronger over time, which is, again, very concerning if you think about resilience and future planning. And the last point is also that we see more and more evidence that short bursts of rainfall are becoming also more intense over time. So this means downpours are intensifying more rapidly than longer duration rainfalls, even though the longer duration intensify as well. So what does this mean for Hong Kong and other cities? There is a higher risk for flooding, for damage, and especially for flash flooding. And of course, if you're in an urban environment, especially close to the coast, and you have steep topography, that's a major challenge.
Possibly.
So there are two types of storms that cause typically the highest rainfall rates in this region and many other regions in the tropics. It's typhoons. You're no stranger to those. This was the most devastating typhoon that hit Hong Kong in the last decades. And there are organized thunderstorms. This is basically a radar image. You saw this from Alexis' talk already from Tuesday. It's exactly these types of storms where you have storm after storm after storm coming over and hitting the same place, the city, and then causing major problems. And again, I have to really congratulate Hong Kong for being that resilient. I was looking outside the window, seeing the rain coming down, and I was expecting way more impact than I saw afterwards. So this is not only a Hong Kong problem, this is really a problem around the tropics. We published a study a few years ago where you can see that most of the tropics are really, the extreme rainfall is coming from these two types of storms. It's typhoons or tropical cyclones and organized thunderstorms. So you can really see it's really all around the tropics and some parts of the extratropics. The challenge that we have really with climate modeling is that traditional climate models cannot simulate heavy and extreme rainfall well. This is a nice study from Europe that shows this very well. This is showing you hourly extreme rainfall rates over Central Europe. What you see in the top right corner is what you get from a 12-kilometer model. This is actually a very high resolution climate model by today's standard. You can see it's an order of magnitude less intense than what you would get from what you see in observations. That these models are really incapable of simulating this very short, heavy downpours. However, if you go to what we call convection permitting models, like these models with a few kilometers, you can explicitly resolve the deep convection numerically. And of course, also you have a much better representation of topography, which is important here, but also in these regions where there are the European Alps. So now if you do this, you see that the observations and the model almost are identical. So you get a massive benefit. Just to further illustrate that, if you, for example, look at a tropical cyclone in a state-of-the-art global climate model, this is shown down here, you can see that it really doesn't resemble anything that you would probably see on a radar image. And if you go to something like 2 kilometers, this is what our numerical weather forecasting models, the regional models are using, or what we use in our climate change assessments, you can see the big benefit after that. It's really visible by eye. So how can we leverage these benefits for Hong Kong and other cities along the coast? I think I wanted to give you a couple of key points that I think are really promising to move forward into the future. First of all, and Professor Chen will talk maybe about this later, but he's leading an effort to simulate a regional climate model for 60 years or even more over this region that will result in unprecedented data that you could use for risk assessment in the whole, the broader area that you can see it. So these kind of modeling have proven to be extremely valuable in other places. And I'm really encouraged to see this happening here as well. And I think supporting these kind of efforts is extremely important. Secondly, the models that we're using to simulate these storms are frequently developed at mid-latitudes. And they're also tuned to work well in mid-latitudes because many of the modeling developing centers are located there. So we did actually a study a couple of years ago where we showed that the best setting in this model that we found for extreme convective storms in the mid-latitudes was the worst setting in the tropics. So this just demonstrates there's really a need to further invest in the development of these models, to further improve them, especially in environments like this, which are extremely complex: ocean, land, topography, and urban settings. So there's great potential to make to improve these models in these regions, but there are definitely there's a need to work on this. There are also other methods that I think are very promising. One of them is, for example, storylines. This would allow you to do something like what-if scenarios. For example, a typhoon that hit the city a couple of years ago, you could ask the question, what would this typhoon look like in a 3-degree warmer world? And the models can show you projections about that. That can help you to stress test, for example, the sea. Another method that we are developing at ETH Zurich in my group is what we call ensemble boosting. This is basically really helping you to get to some of the rarest storm events that are extremely infrequent but very, very impactful. So what I'm showing here in this graphic is, for example, the return period of extreme rainfall from 10 years to 1,000 years. And you see, if you use only observations, the uncertainties are massive. This is the gray area. With this ensemble boosting, you can get way smaller uncertainties, and you can project out to very, very rare events. Again, you can use this methodology. We are testing this now. I have a PhD working on this for the European Alps. I think this would be really exciting and promising to do it here as well. So again, stress testing, the infrastructure, the resilience of the city with this kind of model output. And last but not least, I think also collaborating with others around the globe. There are more and more efforts that use these kind of models on a global scale. We run this on the biggest supercomputers available. My group is, for example, leading this as well, just to show you that these models can give you very granular output for extreme rainfall, for example. But of course, these models can give you more than that. Also the wind speed, high wind speed. So for example, even hail can be modeled by these systems nowadays. So these are my top four. What I guess on most people's mind nowadays is, how can AI help us with that? So I talked about physical modeling a lot. So I wanted to close with these remarks. AI can be extremely helpful. It's an amazing tool. It's extremely rapidly developing, but there's a but. Like me as a scientist, I'm really cautious about that. So I wanted to bring up a couple of points. Current AI models are trained mostly on physical-based modeling output. So most of them are trained on ERA5 or reanalysis dataset, which is quite coarse. If we want to go to small scales, which is really important, we have to get new training dataset. So basically the simulation that Professor Chen is doing here in his group is exactly what is needed to train this high-resolution future climate projection. So AI systems and physical models are going hand in hand. It's not they will replace, it's really the merging of the two that's the future. This is how I see it. AI models currently fail outside of their training data range. This means if you would train an AI model, which most of these systems are on the past climate, and you project them into the future, they fail or are not reliable. Equally, if you look at extreme events in these AI models, they are really rare events. So you don't have a lot of training data. So these extreme events are often not well represented. So being aware of that and really rigorously testing the systems to understand how reliably they are is extremely important. Which comes to the third point, that we really have to look into the reliability. We have to build trust in the systems. We use physical-based modeling since 80 years. We know how these models work. We can look into the physics and understand if they're trustworthy or not. AI is very different. So I think there's really a need to build trust in these kind of projections. But if we have those, like if we went through these steps, these tools will be extremely powerful. What they will allow us is to basically join up with the physical-based models and produce massive data sets that you can use really well for extreme analysis and for building up resilience in cities like Hong Kong. With that, I wanted to thank you for your attention. I'm looking forward to our discussion. Thank you very much.
Thank you very much, Andy. So may I now invite Professor Chen to do the second part of the introduction.
Good morning, everyone. Thanks for coming, and very happy to see you all after recover from all the black days. Now we have a sunny and the clear sky. So I will, Alexis talk about this, and we talk about this, but I want to reiterate on that people, all the participants from international community, really impressed by how resilient Hong Kong is. And that means, the government investment, in the last probably 20 years in terms of the warning system and also the infrastructure, right, to defend the city, really paid off. So I'm going just to rewind, back to another, catastrophic black rain, back to 2023. Probably most people in this room still remember that, right? Which unfortunately, killed 2 people and caused a lot of damage, in the flooding in the metro stations and underground shopping centers. And actually, this rain event didn't break the record in terms of the 24-hour precipitation, only second, but it broke the record for the hourly precipitation, down to 158 millimeter per hour. But it's this type of short duration, intense of rain actually cause more damage, in most cities. Another interesting, thing you notice is in the past, it took about 40 years, to break, the heavy rain record. But in the last 20 years, it take probably 5-10 years. So that's kind of a second, and this point, global warming accelerate, the water cycle, accelerate, the extreme precipitation. Worldwide, this Hong Kong is not alone. So one research group led by Jimmy Fong, at the Hong Kong UST present, what's looking ahead, which the picture is more scary, because by the mid-centuries, the hourly precipitation will be increased, to roughly 240 millimeter per hour, and by the end of the century, it's approaching 300 millimeter per hour. It's scary, but the bigger question is, can Hong Kong, infrastructure designed in the last 20 years cope with this type of the huge jump, in extreme precipitation, and is Hong Kong will be resilient as today, in 20 city years? Big, this is kind of a big question, The other troubling thing is this is the 2025 black rain, and this is Hong Kong, and you look at the hill, and 10 hours before the black rain, it was a clear sky. Nothing happened. At the boom, the deep convection, heavy precipitation developed in a very short time. And it's very difficult, to predict this. As a matter of fact, none of this global model, this is the most advanced, global forecast model from European Center, American model, Japanese model, and the German model. None of them, was able to predict these storms 12 hours ahead of time. So that put, a lot of pressure, for the stakeholders, emergency response team, because they don't have enough time, to do this. But Hong Kong is not alone, If you look at, I have families and friends living in Texas, so I kept an eye on the Texas, flood that happens 3 weeks ago, and fortunately killed more than 100 people, in Texas. But once this disaster happens, people usually point a finger, to the warning system or the lack of the warning system. So these things globally highlight 2, big challenge. One is unfortunately, our weather prediction fail to accurately, forecast the extreme events. Doesn't matter if rainfall or heat waves, all this climate risk. with sufficient lead time. Okay. And another thing is the warning usually didn't reach the vulnerable group, like such in the case in Texas, right? So this is a well-recognized issue globally by the United Nations World Meteorological Organization. Okay, that's why this year the WMO initiated a new project, 5-year project, they call the city urban predict project for the last for the next 5 years. This is a huge undertaking, internationally recognizing this problem. We need to work together, as international cross-border collaborations to solve this problem, to provide a better solution, for the extreme precipitation, for instance, for the cities. Why this project focus on cities? Because that's where the climate risk, weather risk, and the people collide. Very important. Look at Hong Kong, huge population density. When the weather risk hits, the more people get affected. So I had the honor, to co-chair this project with Soleil Ferrari. She's a social scientist, from University of Edinburgh, which is what we need. Not only we need to improve, the physical models, for a better weather prediction, but we need the social scientists, and the urban planners, in our team to really address the second issue is how to improve, the effectiveness of the warning system, over different cities over the globe. So our steering group members, as you can see here, we have 14 of them. They represent 5 continents, over the entire world. So we work together to really find the solution for different cities, different countries with kind of a diverse weather and climate risk, and also with diverse urban governance, and cultures. So in the last 6 months, our team worked very hard, to develop a 5-year implementation plan, which is just approved a month ago, roughly, by the World Weather Research Program, or science community. So now we can actually start working. So this is the overarching goals and approach we are going to take in the next 5 years to address this issue. So essentially we have to take a interdisciplinary and a convergent approach, because nobody can do this alone, and none of a single discipline can do this. So first thing we need to improve the ultra high resolution forecast over the cities, because here very important to recognize the location, the intensity, the duration of the rain. So important, but it depends. It varies. So much. For instance, from central area to Saigon, you make it a totally different precipitation amount, right? So you really need to have a very high resolution, even ultra high resolution, prediction over the cities to provide this information that are relevant, meaningful, to the stakeholders. You cannot just say, we have extreme precipitation, tomorrow for GBA. And so people doesn't know how to do because it's too wide, right? So very important. And the second thing is really we want to enhance the risk communications. Hong Kong is probably exceptional, but in many, many cities, in the world, they even don't have the basic infrastructure to have an effective, warning system that can reach to the people, in time. So the third thing is about, influence the policy and the capacity building. Training, we're going to have a lot of training workshops, train the next generation of scientists, practitioners, to collectively, solve the urban climate adaptation and the resilience. So again, we integrate the physical and the social science and the AI integration, but we really want to stress on the co-design and the co-development, i.e. we try to engage the people from different sectors at the beginning, not just aftermath, So we invite them to co-design, co-develop the modeling system, forecast systems. So I want to mention, two important challenges. One is, the weather forecast now, fail, to produce accurate prediction of the extreme event, particularly in the tropical regions. Andy, mentioned this. I don't want to, because this is very difficult to predict, because the storms are very small scale, has a lot of moisture supply, but it's not really associated with a larger scale as in the mid latitude. It's very hard to predict this, still a big challenge. Another thing is about cities, right? Because we look at the forecast, we say, tomorrow Hong Kong will receive 100 millimeter per hour rainfall. But the cities are not only recipient of the weather and the climate, because the city, they're actually making their own weather. So in the Andy may talk about this, because in the current model, we really don't have a good representation of the city in our model, and their effect on the regional weather and the climate system. That's very important deficiency in the current model. So we need to improve how we parameterize the cities. So fortunately, we have the UST in the last 30 years, thanks to Alexis and Jimmy Fong, they built a team to do the weather, numerical weather prediction, model development. So we leverage this and collaborating with a lot of partners, international partners, to develop this next generation urban prediction model. Again, international collaborations try to connect with this new generation of the weather prediction model. Now we are able to connect the global weather, to the city scale, influence of the city. It's very important. And again, AI is so fashionable, so I cannot stop my talk without mentioning it. But 2 points here. One is this is again the one of the presentation showed at the last few days workshop. 2 points. One is AI is useful to provide the synoptic large scale weather. Seems to be very successful in the Hong Kong observatory, but still cannot capture the very small scale extremes in the cities. So with that, I end my presentation. Thank you very much for your attention.
Thank you very much, the two panelists. May I ask Andy to join us here? And we'll have some chit-chat, and also later on open up the floor to our audience to ask some questions. So so we see promises of the new science and new technologies in guiding us to improve our prediction, both in weather and climate. But first of all, let's have the present status first. Faye, what do you think is our current state of the art performance in predicting the extreme rainfall? And also what kind of metric, what kind of measures we can evaluate our performance?
Yeah, thank you. That's a very good question. My intuitive response is not promising at this moment. Because all the model fail. To capture all these extreme events. Well, one example is about 3 weeks ago, there was a false alarm that the forecast right here in Hong Kong, predicting, you know, the heavy precipitation, but nothing happened. And then people just jump out to complain, oh, Lord, my school is closed, why this happened, why that happened?
The decision was made 2 days ahead, right?
Right. So that shows, you know, how a weather forecast really can impact everybody's life, right? And also the feel, okay, of the forecast. Let's go to metrics, okay, the false alarm, okay, but still we don't have a very reliable, okay, forecast system now to predict this extreme event ahead of time, okay, particularly for the tropical regions.
So it seems that we still has to rely on so-called nowcasting, or the forecasting of heavy rain in the next 2-3 hours. Is it still the state of the art in terms of forecasting heavy rain?
Yeah, I think that's a lot of advance in terms of the nowcasting in the last 5-10 years, and also with the investment in the radar. Okay, and the satellite, so now the now forecast system can simulate, okay, all this information, okay, you know, really to do a better job, okay, to predict into, but we're only with a very limited time, right, 2-3 hours. I think that's a lot of advancement, okay, in that, and that's probably very reliable too.
So I think decision makers should keep in mind of the current limitations.
Can I add quickly that there's also AI-based nowcasting, which is also helpful. So this is another area that is evolving. And I think that we also can like with typhoons, it's probably a different story. Like typhoons, we can predict much better. It's with these convective storms that are the major issue. And there it's really like, I think from a warning perspective, learning how to deal with this uncertainty is extremely important. Like I know we have different warning levels, how to communicate them well. Like you can maybe see that there is a danger, like you had 2 weeks ago, and you can inform, and some emergency management can prepare. But then you have a different warning level, and as we approach, and this is normally done, you can lower or rise the warning level as you get more certainty.
Wow. Yes, so you touch upon another aspect is how to communicate as well, how to be effective, and also to the right people at the right time. Still on the forecasting aspect, Faye, what are the main scientific and technological challenges right now that we are facing in forecasting extreme precipitation and tropical cyclones?
Yeah, I would say probably there are 2 main challenges. One is we don't have a good model. Okay, either a physics model and AI model to be able to predict, okay, these extreme events. We need really invest, okay, on improving the model physics, okay, you know, cloud, how we represent the cloud, how we represent the cities, okay, in the model, which is a very difficult, okay, challenge, but it's doable, okay, with you know, appropriate resource, human resource, and financial resource to develop this. Another thing is to improve the observation, okay, network in the cities. Okay. Hong Kong, again, is exceptional. Okay, we have probably already hundreds, okay, stations within Hong Kong. But in other cities, another different story. But even in Hong Kong, for instance, you don't have rain gauges everywhere, right? And in the mountains, I mean, still this current observation network fail to capture extreme events. Okay, even though we say all 150 millimeter per hour, that's over the one station, but over other places, maybe more, which we didn't really observe. So we need to really invest in the observation network, so that help us to improve the models. Okay, improve the physics models, and that helps to improve the AI approach. Okay, so and also in the models, in addition to making better model physics, and also how we integrate this observation data, which we don't do right now. Okay, in this very dense observation network, in the forecast model, that's still a challenge. How we effectively use them? Maybe with the AI can help that.
Yeah. So are you suggesting that we still go to even higher resolution models? For example, to effectively resolve our terrain here in Hong Kong. We all noticed that our heavy rain in the past few days were closely related to the terrain, and also to reflect the urban city environment. So now I think still the models that we operational use 1 km to 4 km resolution. So are we still going to even higher?
Right.
100 meters?
Yeah, that's kind of the sense I mentioned. Well, we need to ultra high resolution down to hectometers to really resolve the thunderstorms, the airflow, the instability within the cities. So that's the direction to go. And we need a faster computer first. Okay, but
Is it mature now?
yeah, the model, we can run it. Okay, with 100-meter resolution, there's no problem. Models, doesn't crash, but it produces numbers. But can you trust them? Okay, so but because we need increasing the model resolution is just one first step. We need a much better physics. Okay, model physics. Okay, to represent how all the mechanism that produce the heavy precipitation. Okay, including cities, terrains you mentioned, coastline, all this, we need a high resolution. But again, increasing resolution just one first step, but need much more than that.
Yeah. So Andy, anything to add?
Maybe one addition. I fully agree with you, Faye. And I just want to stress also the importance of ensemble forecasting. What this means is you don't have one forecast, but you forecast 40 different situations with different initial conditions. And so weather is really unpredictable in some way, especially convection. So to say if a thunderstorm pops out over there or over there is impossible within hours. Like, it's just chaotic nature. So what we do, we run multiple ensembles, and then you get an average. You say, like, there's a 50% chance the thunderstorm is here, or 50% is over there. So combining both is a big challenge, because if you go to higher resolution, it's more expensive. You can run lower ensembles. But again, like AI, I think is very promising there. You can really use AI models if you train them on this high resolution physical models to help you to understand the uncertainty. And then this uncertainty helps you also to better inform the population. So if you have higher certainty in this ensemble, you can say, like, there's a higher chance that this location should be evacuated, for example.
Yeah, so ensemble forecasting and probabilistic approach. So so we really need to quantify the skills, and also the whether the ensemble, the distribution can actually encompass what we could expect. So do you think, because I remember talking to your predecessor, Christoph Scher, on the use of the ECMWF model for tropical cyclone forecasting. At that time, it was 20 years ago, we started to use ensemble forecasting, and Christoph showed me the chart, and it was really promising. And then now we have everyday use. So for heavy rain, do you think we are now there, or how should we get there?
No, certainly coming back to Faye, like, the model is not, like, we have to further invest in the modeling system. So we know that not all the important processes are in the model. Like in a normal forecast, what you want to see over a longer period of time is that this PDF, this probability of rainfall should match the observations. Not in a single case, but over a longer period of time. Right. And I'm sure if we do this nowadays, it does not. So getting there is extremely important. I think physical modeling can help us to get there, and AI can then help us to fill this PDF, this uncertainty space better.
So what we are saying is what Faye is doing here at HKUST for Southeast Asia, or to have the high resolution reanalysis, that's the first step, right? And then the next step?
So well, we haven't get that yet, right? Okay, so we expect it takes a lot of human and computer resource to perform this 60-year reanalysis, okay, over the entire Southeast Asia, which is unprecedented. Okay, we haven't seen this high resolution data, okay, with such quality and dynamically, okay, consistent, which is critical to use the data set, okay, to train the AI model and help us to improve our physics model, because we don't have really good observations in this region. So that's so next step is really take advantage of the data set to train the AI and our physics model.
Okay, right. So now turning to climate predictions, Andy. So how confident are we in projecting the future climate change, especially in the extreme events? What are the major sources of uncertainty? Because I get it from another tropical urban city recently that they did projection and they found that the rainfall, extreme rainfall given by the models actually varies quite a bit from below the normal average to well above even to 1,000 millimeters in a day. So they were wondering whether the models are usable or not. So what can you say?
So what we truly can say is that extreme rainfall is increasing. Like we understand this physically, we see this in the observations and the models. Like we have multiple lines of evidence for that. Like what the characteristic of this increase is, that's the big debate. And it's extremely difficult to do this for a single point. This is exactly like, because this chaotic nature of the atmosphere gets into your way and the uncertainties become very large. So you can't do this, like you need a large data set, and then you really have to understand the processes as well. Like if, for example, if you know a typhoon, like we expect typhoons to become less frequent, but more intense. Like the most intense events, I mentioned this, they're becoming more intense. So you can look at these processes and then try to understand how much more rainfall would this bring. And that, like as I said, like this short duration, heavy bursts of rainfall seem to become more intense. But there's way more research that has to be done also for this region. I think there's not a lot of research in Southeast Asia on this topic, also because there's lacking observational data sets. But additionally, also how the storms look like, the morphology of storms is changing. This is what we see as well. Like cyclones seem to contract and produce heavier rainfall in their center. So if you're hit by the center of the rainfall of the cyclone, you might get flooded way more than before. And additionally, the same thing seems to happen with thunderstorms. Sorry for that, with thunderstorms as well. Like, and these are the research questions we have to answer, and then especially looking at these rare events, because those are the events that cause impacts. Like we really, like, and again, like we have to collaborate with you. Like you are on the ground, you know what the impacts are. We have to understand what are your concerns. Like, are you concerned about the 1 in a 10 year, 1 in a 100 year event? What is the major cost that you would expect from these events? And then we can try to understand how these storms are changing.
Yep, yeah, we should work together more. Yeah, I'm also very interested in AI. And what we have heard is it holds promises in the larger scale, for example, in for more accurately predicting the tropical cyclone tracks, but not so much in the high resolution, the fine details of the extreme rainfall patterns. So another thing is, well, of course, we need to go to the use of higher resolution training data sets. That's, I think, this very clear. But how about the physics in the AI models? Are you also working in that in order to improve the performance in the resolving the terrain, in resolving the very fine scale features using AI?
So the current AI systems are the physics in these systems. Like there's actually no physics. Like it's very different approach. Like it's data driven. Like these models don't learn about microphysics, about convection and so on. They learn it from the data. So this means these systems are only as good as the data that you provide. Like, again, coming back to the importance of improving models and to get this high resolution training data sets to have these AI models. Like you cannot trust them blindly. And coming back to your, like the track is, like these things are, because they're on a larger scale, they can do this extremely well. But for example, the intensification, this is also something we expect from climate change.
Yep.
Rapid intensification, typhoons, tropical cyclones seem to intensify more rapidly.
Yep.
It's a major challenge because this happened in Mexico 2 years ago. There was
Also
a tropical storm
near Hong Kong.
on
as
Hong
well.
Kong.
Yeah.
Just you see it on the previous day, it's a tropical storm. You think, oh, there will be a little bit of rainfall. 24 hours later, it's a Category 5 hurricane. And these models are the physical models, but especially AI models cannot do that. Like we have to really get this again. We have to understand the processes, do this better in the physical models, and then we can train the AI models on that.
Yep. So it holds promises, but I think further work has to be done. But how about the what HKO shows us the other day is using an AI model to provide the background flow for the boundary conditions, and then use a high resolution model coupled to resolve the fine scale feature. Is it also a promising approach?
Yeah, I think so. That holds promise in the future. Although there are still questions how to integrate this. Okay? Because I mean, in terms of the atmospheric science perspective and numerical weather prediction, the AI model, as you said, is they learn from the past, but they are all the wind, wind, humidity, temperature, they may not be even internally consistent. So how you use this to drive your meso scale model is still a question. But I think a lot of we have heard from several groups. Okay, at the workshop, they are working on this. Okay, they invest their time. Okay, try to improve this kind of integration of the problem. And this is also the one of the important tasks for this WWRP Urban Predict, how to effectively integrate the AI approach and the physical models. So it's promising, but we're not there yet. Okay.
So maybe one last question for me is now, of course, we are in Hong Kong and we just experienced our rank 7 highest daily rainfall on Tuesday. So from each one of you, can you suggest 2 recommendations for us here, no matter it's observatory or the university academia, what we should work first to further improve our predictability of the extreme rainfall?
For the predictability, I think really investing in the local model development. To really, like, this is a very special place. I'm also impressed by the location of the city. Like, it's next to very steep terrain. Like, this makes it way more challenging. Very urbanized, very vertical city. Like, you have to really get a good model that can represent this setting well.
Good.
And then I think like this AI integration with the physical modeling, I think this is a very promising pathway to go. Like, but it's really both things that you have to work in parallel. I think like, I have to stress this again, like the physical models, like this is probably, I'm a physicist, so this is close to my heart. Like, we have to have trust in these models. And to gain trust, you have to understand what's happening. And that's why I think the AI models, I'm a little bit cautious at the moment, because you can really hardly understand what they do.
Good. Faye?
Yeah, you cover very well. I fully agree. I think the one point I want to add on is to invest on observation network. Okay? And that helps to train our physical model and further to train the AI model. That's critical component.
So do you mean the conventional meteorological data, observational data, or even the community-wise big data?
I mean all. Okay. But,
all.
Yeah,
The more the better.
all of them. Yeah, more is better, obviously. But also, this is still a challenge in terms of unconventional, citizen, crowdsource data, because they observe with different instruments, sometimes with their cell phones, right? I mean, how you quality control them, so they can be effectively used in the weather forecast. But still a challenge. But at least we start working on that.
Okay. Now I think we still have a few minutes, so I'd like to open the floor to any question you might like to ask for our panel. 冇哥, Mr. Leung, our local KOL, most known on TV.
Thank you. Good morning. I have lots of questions, but for the sake of time, maybe I just ask one. As Director Chen said, I'm the spokesperson of the Hong Kong Meteorological Society, so I've been talking to the reporters quite a lot lately. And one of the questions, difficult question is, how the rainstorm has been made worse as a result of climate change? Can we quantitatively give a kind of feeling to the reporters? So my question is, can the models, I mean, Professor Chen, can you run the models and then give us an estimation of how much climate change play a role in this kind of rainstorm? Thank you.
Attribution.
Yeah, attribution. Yeah, indeed. I mean, there are a lot. I mean, we are doing this at the Hong Kong UST, right? Produce the very high resolution climate data set, not just for the past, but also for the future projection and the global climate change. And many people actually in this room probably involved in that type of activity. So I think yes, the answer is yes. And also in terms of the uncertainty that Andy mentioned, I think what we have seen is all the models, very high resolution models, they diverge by the end of the century in terms of how they project. I will not use the word forecast, but in terms of climate projection, by the end of the century, they diverge really. I mean, that's a large uncertainty. But if you look at what happens, in the mid-century, say 2050, 2060, the model actually converge, in terms of temperature, there's still difference between them in terms of predicting the extreme precipitation, but taking all of them from the ensemble perspective, so there's still reliable signal to us.
Can I add maybe quickly? Like, what I like to say in this kind of situations is like, every kind of storm that we see nowadays is affected by climate change because the background has changed. Like, this is an important point. And then secondly, this attribution is a first step that you can really pinpoint, like this is the percentage of intensity change. But it's what we expect is approximately 7% per degree warming intensification. This is because the moisture in the atmosphere, the saturation vapor pressure is increasing at this rate. So that's a safe thing to say at this stage. But I think you're aware of that. Yeah.
But just to add on that, 7% is about the average precipitation. But there are some studies showing, at the workshop, an extreme, precipitation increase faster.
Right.
Quick. I mean, than the 7%, sometimes 10, 14%.
Around the tropical storms. Yeah.
Particularly in the tropical regions.
Yep. So any other questions, please?
Hi, I'm Veronique from HKUST, the business school. I wonder how, your efforts are amazing and it's very, very interesting. But how are your efforts and model developing affected by the current U.S. administration's efforts to dismantle scientific research?
Oh my God. I know that some has been affected so that they can't participate here face to face.
We both worked in the US for a very long time, and we moved away, not because of this situation, but before. It's a very uncertain situation still, like as far as I understand. It's still uncertain how much funding cuts will affect model development and so on. Like, this will be shown in the next couple of months, years. It's a very serious situation because I stopped using US models, not just because I moved to Europe and started using these models, but many people, including people here, but also people in Europe, they are using US models, not only the models, but also data. Like satellite remote sensing data is extremely important, especially for tropical cyclone forecasting and so on. Long-term data sets, we are afraid that these data sets will disappear. So there are rescue efforts. So this is a very serious issue that it's hard to say how it will unfold. I'm an optimistic person, but you have to also think about worst case scenarios.
Right. Faye, anything to add? You're using a US model right now?
Yeah, we're not only using, US model, we are developing it. Okay, so I mean, I think the international collaboration, cross-border is very important. I mean, it's a pity, to say, the current situation, and it's probably have a long-lasting effect, right? Even after the Trump administration. But I certainly believe we have really weathered a lot of storms in the past, over different administrations, and the science community is very resilient. The public can cope, hopefully, to this situation. And last week in Singapore, Alexis and Jimmy Faye and we met with the NCAR, National Center for Animal Research. That's where we develop a lot of models for people to use. And I mean, he, the director, his assessment is for the next bill now on the desk of Congress in terms of the science, investment to the National Science Foundation looks better than 2 months ago.
Yeah.
So that's the silver lining among all this.
Okay, so I guess we need, we have the keyword resilience, not just the climate resilience, but other resilience as well to navigate these troubled waters. So I think we now need to break because our next session, next panel will start at 10:50. So why not we continue our dialogue during the coffee break? Thank you very much.
Thank you.
So maybe I would invite Christine to help us moderate the second panel. Yeah.
Well, thank you very much. Thank you for staying and being here with us. We have heard the first panel and the speakers, and I think that was a good summary that Professor Chen Faye and Andy shared with us. So we want to go forward now. So for the next panel, we have 5 speakers. They're all going to speak for only 6 or 7 minutes, but we want to start with 2 scientists, Professor Jason Evans and Dr. Faye Cruz, who will take us from the science, link up with what was said earlier in the morning, and then we will have 3 speakers from Hong Kong to, again, link it back to what we're doing right here. After the 2 scientists, we will have the director of drainage services, the star of the show. And after that, we will have Woody Chen representing a property company, Link Reed, and then Clement Hau, who is with the Hong Kong Federation of Insurers. So what we want to do, in a way, is to link the discussion we have already started. How do we look at the science, and then what we have to do in a city to be resilient, and then how actually all of us, and I think we have all of you here because we're beginning to understand in the financial sector, in the insurance sector, in the property sector, in the government public sector, we all feel that we need to know a little bit more about science. We're not all going to be climate scientists and physicists, but we need to know enough to understand how we collaborate with the scientists, because they're going to keep going forward on the science. And then we need to work with the public sector, the government who's in charge of infrastructure in the public sector. But also, of course, many of you have private infrastructure and properties. How we deal with that. And in the morning, we already talked about the importance of early warning, which is an issue for the rest of us. How do we get ready? So can I invite the first 2 speakers first, Professor Jason Evans first, and then followed by Dr. Faye Cruz. Please.
Okay, thank you very much for inviting me here today. So I'm based at the University of New South Wales in Sydney, Australia, and I'm going to share with you a few Australian experiences of climate scientists collaborating with government and industry to help them with dealing with the changes that we're experiencing and expecting into the future. I'm going to give two main examples. The first one is a collaboration I've been doing for quite a while now. It's a collaboration with the New South Wales state government, and it has expanded now to include a number of other state governments in Australia. And it's really based around the production and use of regional climate projections for the government departments to do climate risk assessments and adaptation planning. Now, part of the motivation for this was that they didn't have the information at a spatial scale that was useful in the planning. So that's part of what we helped develop together. And the other part was that all of the different government departments were using different data sets around climate change. There's many data sets out there. They're all using different ones. And through this process, we developed a single data set that was comprehensive enough that all the government departments could use the same data set and do planning in complementary ways, often collaborating together. Now, it also underpins the government's communication to the public. So there's a website called Adapt New South Wales. You can visit, you can go through the interactive maps and go through the projections for your area and have a look at what's happening. Anyone can do this. The URL is there if anyone's interested in checking that out. And this collaboration has been going for quite a long time. So I started working with this government team in 2011, so quite a while. Now, or a few years ago, the government actually created its own climate science team. So they hired a team of climate scientists and have developed an in-house capability in the area. And that's been a big step forward for them because having this team in-house means that all the government departments have someone to go to for advice at any time. Now, I did my best to give advice as I could for many years, but I couldn't be there all the time and I couldn't be on call for them. They have a team now that is there all the time and is always there to help them. And that's been a really big step forward. This project overall has, I would say, is an example of a really good, successful collaboration between the scientists and the government departments. The data is there and available for everyone, not just the government. It's open data. And in the last probably 5 years, I think the entire government has gone through a process of risk assessment and adaptation planning. And this is the data that underpins all of that work. So I think from all perspectives, it's been really quite successful. So the next example I want to give is maybe exactly on topic for the extreme rainfall we've been talking about. And this was work I was involved in where we were updating guidelines called the Australian Rainfall and Runoff Guidelines. Now, these guidelines were developed by Engineers Australia. They are written for engineers. They underpin the best practice methodologies for how you actually design water-sensitive structures. So how you actually develop flood estimations and design your structures. It's not a legally binding document, but through the court systems in Australia, it has ended up almost being treated that way, because if you have used the methodologies in these guidelines, it's considered best practice, and that essentially it makes you immune from anyone later on wanting to sue you for any incident that might happen. So they're really important guidelines, and they're actively used in industry for flood estimation and design. And up until a few years ago, there was no consideration of climate change in these guidelines at all. So everything in the guidelines were based on historical data, and that was all that was considered needed until recent decades, when the historical data didn't seem to match what was observed events that were happening. So as part of the update here, you can see the climate change considerations chapter that is now in there. I was one of a team of climate scientists, hydrologists and engineers, and we went through a process of assessment of all the scientific literature and research in the area and come up with an additional part of these guidelines where we brought the climate change in. And just to show you what ended up in the guidelines, through this collaboration is this main finding here, where the central estimate for the extreme rainfall is split by duration of rainfall. And for durations of 24 hours or longer, you add 8% per degree of warming. So depending on how far into the future you're looking, you have more warming, and you need to increase your extreme rainfall estimation by 8%. But you can see for the very short durations, less than an hour, we found a much stronger increase. So here you have to add 15% to those. So, and I'll just highlight here that this goes from everything from a exceedance of 1 per year all the way up to the probable maximum precipitation. So if you're looking at probable maximum precipitations, these are quite large increases. Of course, you then need to consider what future climate change might happen, so then we also look at different time horizons and different emission scenarios as well. So what are the implications of this? Well, it means that for the same level of risk, structures now have to be designed to withstand higher flood levels in Australia. Okay? Now, that often means there's more cost associated with building the structure. So it hasn't been seen favourably by everyone necessarily, but it does mean that the structures are actually resilient to the level of risk they're designed for, because we're accounting for future increases. And it also means a recognition that we have a lot of existing structures that were designed to some historical risk level, which is not what we're experiencing now or expecting in the future. So there's a lot of structures that we have right now that cannot withstand their intended risk level that they're meant for. So there's some issues that will remain because of that. And I'll finish there. Thank you.
Thank you.
So good morning, everyone. I'm from the Manila Observatory in the Philippines, but I'm also part of a regional collaboration of climate scientists in Southeast Asia, and we call our group the Cordex Southeast Asia. And I'm here to share our experiences in the Philippines in bringing climate science to society. So observation records have indicated that the extreme events have been increasing in these past years, and it's not just happening in Southeast Asia, but also in all parts of the world. And examples of such extreme weather events are floods and storms, which are actually among the top causes of natural disasters in the Philippines in the past 30 years. And this has caused significant damages and loss of lives in our country, and placing our country at high climate risk. So actually, in the World Risk Report, since 2011, the Philippines have been consistently among the top countries at high climate risk. And this is because of the exposure of the vulnerable communities and ecosystems to multiple hazards. And so, as we've heard this morning, we are anticipating more extreme events, more intense and more frequent extreme events, and we really need to have access to robust climate information so that we can, properly plan for such events. And high-resolution climate information is necessary because we can get those projections from global models. It's available, but it can be a bit problematic for areas like the Philippines with all of the islands and areas with complex topography because the global climate models have coarse spatial resolutions, and so we need to have these higher spatial and temporal resolutions. So as an example, I show here the projections of rainfall for the Philippines, that when we do these downscaling techniques, we are able to see more detail in the projected changes in rainfall, and you can see that there are areas that will experience drier conditions and some wetter conditions. And it's important to have high resolution to capture the extreme events, which we know will have very pronounced impacts on society and ecosystems. And these impacts vary from place to place. So as an example here, we could see that the areas which experienced high economic damage due to tropical cyclones are not necessarily the areas that have experienced more tropical cyclones. So at the Manila Observatory, we have then used these high-resolution climate projections to provide information on hazards that we can use to combine with data on exposure and vulnerability, so that, for example, working with local governments, we can identify what is their risk profiles, and so they can plan appropriately, and more importantly, to avoid what we call maladaptation. We are, well, for example, Cordex Southeast Asia is continuing these initiatives in providing high-resolution information. For example, we are updating the climate scenarios for Southeast Asia, and we are also interested in providing information at city scales. As you know, we wanted to see how climate change will look like for Southeast Asian megacities. So apart from climate models, we can also get information from observation stations. We've heard that this morning about the importance of establishing and maintaining a dense network of observation stations. So thankfully, we have access to satellite data, which gives good spatial and temporal coverage, but it's not enough. We still need to have these ground-based observation stations to complement those data. And at the Manila Observatory, we are fortunate to have to be able to maintain a network of automated weather stations in cities and in different parts of the country, with support from the local government and also from the private sector. And so we use this information to analyze and understand what are the causes of these extreme rainfall events. And so as an example here, we find that in Metro Manila, during the monsoon season, the extreme rainfall events are mostly due to the thunderstorms or these short-lived, intense events. And it's important to also have these observation stations because we could use that to see how our models could still be improved. And also, as we've also been talking already of AI, this can also be used as training data sets. So aside from observations and climate models, we get regional climate information from scientific literature, from experts, and from process understanding. But it's also important that we get input from the vulnerability impacts and adaptation communities, from decision makers, even incorporating indigenous knowledge so that together we can co-produce this climate knowledge that's useful and relevant. So as an example, we've had opportunities to connect with local stakeholders and city planners in our projects. And in this example, this was a recently concluded project, the Climate Resilient Cities project that was funded by USAID, where we had an opportunity to hold these, what we call Climate 101 workshops. And in these workshops, we have a chance to explain how we are producing this climate projection information for the cities, and to also have a discussion on how they can be useful for their planning. So before I end, I'd just like to mention about this climatic impact drivers. I'm not sure whether you're already familiar with it, but this was introduced in the last IPCC assessment report. And it tries to help us translate these physical conditions of the averages, events, extremes, into what they can mean for society and ecosystems. So it could be, the CIDs could either be describing heat and cold, wet and dry, snow and ice, wind, coastal oceanic, and so on. And what's interesting about this concept is that it's not just looking at the physical changes in climate, how much temperature is going to change or rainfall, but to see whether there are thresholds that are going to be exceeded wherein those changes will have these significant consequences for society and sectors. And so this is also introduced, the climatic impact driver framework, where it is a way to process climate data into climate information that's useful for decision making. And it has a neutral approach to climate change in that the drivers can have beneficial, detrimental, neutral, or mixed impacts depending on the response and maybe the sensitivities of the affected system or sector. So it is also a way to encourage the co-production of information between the climate scientists, impacts and risk experts. And so together we can co-produce this climate knowledge for effective climate action. So that's all. Thank you.
Well, thank you both for making, I think, very complex things relatively simple. Well, the star of our show today is Ringo, the Director of Drainage Services, because everybody wants to know how you did it. So if I can invite Ringo to give us his presentation.
Okay. Ladies and gentlemen, good morning. Have you ever wondered what our city will look like in 25 years if flooding due to extreme weather event continues to devastate our community unchecked? In the next few minutes, I will share with you what we have been doing in the past, the present, and future to enhance flood resilience in Hong Kong. So please fasten your seatbelt. I'm Ringo, the Director of the Drainage Services Department. Let's start with the cause of flooding in Hong Kong. With the unique setting of our city characterized by high annual rainfall, high hilly terrain, high density of population and development along the coastal areas, we are facing the challenge of flash flood and coastal flood under the combined effect of torrential rainfall, rising sea level, and storm surge. Our past flood investigation indicated that many flooding cases have been due to blockage of road gullies by leaves, sediments, and debris carried by rainfall and runoff to drainage inlets, landslide causing blockage of catch water, rendering drainage system unable to perform as expected. Over the years, we have adopted a three-pronged approach to mitigate flood risks through implementation of drainage infrastructure projects. We have carried out improvement works for the downstream drainage systems. Besides that, we are now building the first tidal barrier in Hong Kong to tackle the rising sea level and storm surge. In midstream area, we built underground storage tanks to capture stormwater for temporary storage, thereby relieving pressure of the downstream drainage systems. We also built drainage tunnels to intercept and divert stormwater from upstream catchment areas to the sea directly. This can further relieve pressure of the downstream drainage system in rainy days. Since the establishment of our department in 1989, the government has invested over 32 billion Hong Kong dollar in drainage improvement projects. In the light of more reports published by the IPCC over time, we realized that a more holistic and sustainable solution is needed. So we embarked on a strategic planning study in 2022 to formulate a new flood management strategy. Last year, the study was completed. It reaffirms our three-point approach and recommends an integrated flood management strategy comprising three key initiatives, namely adaptation, resilience, management, known as the ARM measures. For adaptation, under our new strategy, we will first focus to mitigate flood risk to the mid-century. Now, 15 drainage improvement projects are under construction, including 9 underground storage tanks. Towards the end century, we will adopt a progressive adaptive approach to implement drainage infrastructure in place with the development of climate change. There is a consensus that it is impossible to pursue drainage infrastructure facilities that can eliminate flooding. Therefore, resilience aims to adopt temporary or non-structural measures to control flood risk and reduce flooding impact for speedy recovery of the community is essential. For instance, floodable open space will be provided in new development area. They adopt the single-site multiple-use concept and serve as regional parks for leisure purpose. During extreme weather events, they will be turned into temporary flood retention facilities. We also promote the blue-green drainage infrastructure concepts. Elements like green roof, stormwater harvesting, and engineered wetland are examples of our blue-green drainage facilities. Use of various types of flood barriers can minimize flood impact due to water ingress. In addition to traditional flood barriers, we have adopted new generation of flood barriers, including auto flip-up barrier, water-filled tubed barrier, doorway barrier, and etc., to enable rapid and efficient deployment of flood barrier under diverse settings. For management, we leverage innovative technologies to strengthen our early warning system and effective communication with the public to provide first-hand information. We have identified about 240 locations which are prone to blockage. Upon receipt of early warning from the Hong Kong Observatory, our teams will carry out just-in-time inspection and clearance. If the weather gets worse, we will trigger and activate our Emergency Control Center to oversee our emergency response and recovery services. Since 2023, we have increased the number of emergency teams from 70 to 180, and also the number of emergency support stations from 13 to over 30. These measures are effective. As a result, all flooding cases happened in 2024 could be handled and removed within 1 to 2 hours. To leverage innovative technologies, we are conducting a pilot project on AI flood monitoring with a will to enhance our capability to detect and monitor flooding. We have proactively applied robotic technology and have developed a series of robots to fulfill our operational needs, including inspection, desilting, and pumping. This year, we further empower our robotic squad. We procure 6 high-capacity pumping robots to enhance our emergency response for extreme rainfall events, aiming at ensuring speedy recovery. 3 of these robots are called 龍吸水 in Chinese. In English is long sea shay, which have been widely reported by the media during the and after the bad rainstorm events happened early this week. Now, let's take a look at how our pumping robot, 龍吸水, tackled the flood at Queen's Mary Hospital during the bad rainstorm signal on this Tuesday.
我可以撳低少少，我一陣間會撳低少少吸到嘅。
Our robot is a wireless remote control with high mobility and flexibility, processing pumping rate of 800 meter cubes per hour, capable of continuous operation for a long time. During the rainstorm on the 4th and the 5th August, these 3 robots were deployed to various flooding locations in Hong Kong, including the car park in Cheong and Queen Mary Hospital. On flood monitoring, recently, we have put in place a new measure called waiting light system. We install flood monitoring device along the road curbs and plant visible waiting light on the road. This device can detect and measure depth of flooding, which enable us to take timely emergency actions. We will continue to rebuild and update relevant standards and guidelines whenever is needed. On a regular basis, we engage the community to raise public awareness and preparedness for extreme weather events, such as stakeholder engagement meeting before every rainy season. To conclude, this table summarizes examples of our ARM measures under the Integrated Flood Management Strategies. To forge Hong Kong into a flood-resilient city, we are committed to implementing the Integrated Flood Management Strategy and adopt the ARM measures under a progressive adaptive approach. This concludes my presentation. Thank you.
Ringo, thank you very much. You know, when I was in government, I worked with, I think, 3 or 4 directors. And I always said that my favorite department in government was DSD. But when I tell the public that, they would say, who? So in a way, some of our most amazing government departments in Hong Kong are relatively unknown to the public and even more unknown outside Hong Kong. So anyway, we'll have now 2 people from the commercial sector to come and talk to us. We will have Woody Chen from Link Reed, followed by Clement Hau of the Hong Kong Federation of Insurers. So please, Woody.
Right, morning all. Let me give you a whirlwind tour of how Link approaches climate risk and climate resilience. For those of you who might not be familiar, Link Asset Management looks after 130 properties in Hong Kong, most of them in non-discretionary retail and also car parks. And a point of note here is also that Link's properties are mostly legacy assets. A lot of them are quite old. The average age is over 30 years. And some of them are even built from the 1970s. So with that asset portfolio, extreme weather events really, for us, is an operational reality. Most of you in this room would have seen this photo from 2023, when Temple Mall in Wong Tai Sin was flooded. You cannot see it in this photo, but you know that's 3 meters of water in that basement floor. 8 of our tenants were affected, and they couldn't do business for 54 days until we could recover that floor. A lot of you have already asked me this, but this did not happen in the past 2 weeks, so that's good. And that's, of course, due to some new climate resilience measures that we've put in place, but also a lot of the work that DSD have done since 2023. So, what did we actually do afterwards? The conventional response is reactive. So we would, of course, clear out the debris, fix everything, but then also file claims for the damages, absorb the losses, and brace for the inevitable impact in terms of insurance, premium hikes. Link chose a different approach. First thing we did is we revamped our entire approach in terms of climate risk assessments. So what we did is we looked for an insurance company and said, can you do risk assessments for us? Why we did that is because we want to know what the impact is financially. What is the impact to our property damage, business interruption, but of course also to quantify what the biggest risks are and how big that impact would be. So this is just a snapshot of what that looks like, and you can see that in Hong Kong, Shanghai, and also in mainland China, in general, tropical cyclones and floods are the biggest impact. So that's on the assessment side. But the main thing I want to point out is that we have to also be speaking to our insurance counterparts. And what we did this time is we organized a roadshow through our broker Marsh, invited 22 of our insurers into a roadshow and basically communicated to them what we did in terms of risk reduction. And here is a snapshot of that. So since the flooding in 2023, we put in $8 million Hong Kong dollars into a range of hard and soft measures in terms of flood resilience. So softer measures would include drills in terms of flooding and typhoons, making sure that our frontline staff know what they're doing in terms of the standard operating procedures. If you gave me a sump pump, I wouldn't know how to operate it. So the key thing is making sure that we don't just have the equipment, but we have to make sure that our frontline staff know how to actually operate it and know when to operate it. What are they going to do when it's yellow rainstorm signal? How are they going to react if it's going to be red or black? So that's the kind of soft measures that we have to put in place. But the harder measures, of course, the flood barriers, the IoT flooding sensors, just simply replacing our drainage covers to larger gaps has a huge impact in terms of efficiency. So all of these would be the harder measures that we've put in place as well. And this is just a snapshot, not just of Temple Mall, but across our portfolio as well, in terms of the highest risk properties, including in Chai Wan, TKO, and also in Wong Dai Sin, of course. And one thing I want to highlight also is the engagement part. We can't be resilient in isolation. We need the support of everybody in that area, including the district councillors, including the government departments, including even our peers. A lot of the water that came through into Temple Mall that year was because the MTR shut down their flood barrier, and that was rediverted into our basement. I'm not saying it's their fault, of course, they have to protect themselves, but we need to be coordinating with everybody in that area in terms of resilience. A lot of the debris, a lot of the mud that came into the basement was because there was construction nearby. How can we work with them to make sure that that doesn't happen again? So with that, at the same time, we also talked to one of our insurers in terms of a resilient, sustainability-linked insurance proof of concept. With insurance, they have exposure as well. When we get hit, they get hit. So how can we work together to make sure that we can help them reduce their risk and also get some return in terms of adaptation measures? So what we asked is, given the risk assessments that we have done, given the measures that we have put in place since, what does that mean in terms of our premiums? What does that mean in terms of insurance terms? So what we quantified from that study was that with the measures that we have put in place, we can bargain or negotiate for a premium reduction of 10 to 20%. And off the back of that, for our 2025 renewal, we managed to get an 11.7% premium reduction, more than triple the average decrease in the real estate market. And on top of that, for the second year, there's a condition that if our loss ratio is below 60%, we get an additional 7.5% in premium discount. We'll see about the 60%. We're trying our best this year, but 4 black rainstorms might be pushing it. And so, of course, our brokers are great, but we want to also show that it's not just them being very good at negotiating. Our insurers have also come out and said that the premium decrease is because of the climate resilience measures that we have put in place. So just to wrap up, we want to say that climate resilience is not just a defensive measure. It's not just to protect value. There is value creation in that as well, actual tangible financial returns. It's not just a risk response. What we're trying to do here is it's a win-win solution we're trying to get with the insurers. We're not saying that resilience-wise, Link is doing the best. There are plenty of real estate peers who are doing great stuff as well. What we're trying to point out is we need to start talking to the insurers and create that ecosystem where we reduce their risk and we are incentivized for that as well. That's it from me.
Thank you.
Thank you.
Clement.
Hi everyone, I'm Clement from Hong Kong Federation of Insurers. So I haven't prepared for that because I haven't met Woody and I don't know what he tried to talk during these things, but thanks for setting up the scene from Professor Law and also Woody. So I'm representing the Federation of Insurers. So today, basically, I'm also coming from an insurance company, but not that company he mentioned, but from another company. But today I'm representing the industry. So I think today I'll try to give a short presentations from an insurer's perspective. So basically, I will mention a little bit about as a federations, as a insurance, the industry union, what we have done, but that is the introduction. But more thing is actually on the technical side from an insurer perspective, how we see that, okay? So, but that thanks for Woody for putting up quite a lot of scenarios, things that, so I can skip those things, okay? So I think it's a broader sense about the climate change things. Hong Kong FI also have a green insurance task force. Actually, they have also, we roll out this kind of, climate change things as well as the, also the first ever climate charter that actually is more the commitment from the insurers. I think it's more on the PR things and also the commitment things. So, but today it's more talking to the scientists. So I will leave it here, but at least basically from a industry body, we also push for the climate change that's happened, okay? So I think I will share a little bit more from an insurance technical side. Just like what the introduction from Professor Lau, so every time when there's a self-invited guest come into Hong Kong, I will receive those kind of videos from social media and those things saying, well, what are we covering? Being covered. So that's why I put these first slide things. I think I don't need to explain too much on insurance, right? So insurance is the risk transfer mechanism. We provide that financial remuneration for those for the event, unfortunate events. So insurance is the risk transfer mechanism. Today I'm representing the industry. I would say insurance is the safety net for the society. It's one of the very important things. So before you ask me, so I just put the second half here. First thing is, in Hong Kong, we are that fortunate. So we have this kind of coverage. So basically, as long as there's a property or risk policy or fire perils, you have that perils, basically you're covered. Always receive those videos about the flooded cars. Basically, you have comprehensive cover. You have that. So why I just pointed this? Because this morning, right from earlier this morning, we mentioned about the resilient things, about the protection things, and also and glad to see we have that impressive things to the external guests there. So at the safety net, we also very resilient, okay? So we have that cover. Because just give some context, it is not a must to have this cover. Just like 20 to 30 years ago before the Western District reservoirs built, so those dry seafood shop, they can't get the flood insurance. That's oldie things. And also some of the countries and some of the regions, actually the natural catastrophe is actually separated. It's a separate insurance. Like I think just now during break also somebody asked me about the California bushfire thing. So this kind of nat cat things is separate. So in Hong Kong, that's fortunate. Don't worry, we have these things, the safety is working. But one other thing, why I like to talk about this safety net, just like the circus show, right? So we see the safety net, but you're not expecting everyone just follow the safety net, then that's a problem, right? So when I say insurance is a risk transfer mechanism, so not because I'm an insurer, I don't want to pay out, but actually as long as we pay out, that means damage has been made. That's the key point. So we have the safety net, but we will try to prevent those things happen. So that's tied back to the discussion today, right? So I also shared this in previous events. One of the things that we have is actually as an industry, we have this kind of information. We have the loss data. But one of the things that today I think is a very, very fantastic event is like in front of all the scientists here. So just now also mentioned, so climate change might be, there's a possibility we'll find out the quantified those climate change. But just now, the two speakers also mentioned, heavy rainfall doesn't mean there will be a loss. So there will be a gap there. So we have to be, so this is for illustration only, because actually this is, as a federation, we try to ask our member company to voluntarily provide these numbers. So we're receiving this kind of data, summary data, for every black rainstorm as well as typhoon signal number 8. But it's a voluntary basis. But the good thing is actually we also represent around 70% of the market share. So basically we got the numbers. Moving to that thing is actually, I think just now we talk about a lot of challenges, right? So I also speak on behalf of the industry. So our challenges is on the data limitations. So we also have some friendly reinsurance company here, friends here. But you know, in the past, I think Hong Kong is just a very small spot at the southern coast of China. So basically, quite a lot of model that we are using is actually the regional model. Is just like Professor Chen just mentioned about the resolution things. So basically, Hong Kong is just two squares, okay? So I think one of the things is actually, we don't want to see it from an insurance perspective. It's like, because we see the event come up more frequent, the price will go up, right? So that's why from our perspective as an industry, hopefully we need to have that kind of resolutions. Okay, so that means actually this is something that we want to move forward. So that's why I mentioned about the by location basis, we have the difficult things. And then the second thing is, I try to lead in like this, is what if we put our loss data to the rainfall? What we will see, huh? So basically, I'm not a scientist. So I put a graph there, there's nothing there because we can't see anything at all. Because actually one of the things that I would want to bring in for this event is just like what I'm saying. So heavy rainfall is not directly proportionate to the loss amount. There's a lot of things happen. So that's why from the challenging thing is actually as an industry, we hope we can work with different partners, with the community, with the government data. Actually, we will find causation. So if everything is just direct proportionate, it's a linear relationship, then it's simple. But just now, the two guest speakers also mentioned it. It's not a must. The resilient things is actually how you protect that. But what we want to try to do is actually, we have a good asset as an industry. We got the loss data. So how this loss data will come up with the science things, combined to become from a science to application. So I think that's why I mentioned about, so how we can find out the correlation between the loss data versus the different climate factors, or even other manual factors that just now mentioned. And also the high resolution, definitely, the precisions, definitely we need that. Because actually we will have to defend, well, we are a very good city, we have the resilience things, so that's how I see that thing. So let me stop here. So, yeah.
Okay. Thank you. May I ask the panel to take their seats here? And whilst they take the seats, I mean, you know, I'm a generalist, but the sort of things that I have learned from working with my scientific colleagues and also with policymakers and others is that we're going through a tremendous learning process about climate change. And before, I think we used to take the climate for granted, but now that we know it's changing very fast and in a very big way. So one of the unifying points that you've all made here is we need to learn more across disciplines. And secondly is cooperation. So perhaps we can use this as a main focal point for our discussion. But perhaps I can start with the two scientists. I think during your conference in the last 3 days, you talked about the UN early warning system, you talked about UN bodies, codex, and so on. So on a kind of international and regional basis, and then zooming down to the Philippines, Australia, Hong Kong, and other parts of the world, what is it that these regional international collaboration, how can they help us on a more individual locational basis? Either one of you like to go first?
I can do that. So the climate system by its nature is global. So it affects us all wherever we are. And there's been, for many, many years, efforts in all around the globe to improve our understanding of how it works, our models, so that we can actually predict what might be happening. But there remains a lot of uncertainties and things that we're still investigating to try and understand the real details of how these things go. And the net result is there's certain types of events that we still don't predict very well, as we heard earlier. Now, through international collaboration, it allows us to look at the efforts that have been happening in other parts of the world, the way they have developed their models, the way they've implemented their understanding of the systems into their models, and how that affects their predictions. And we can compare that with our own models, our own predictions, and learn from each other. And that's really driven this as a global enterprise to improve our weather prediction and our climate projections. Now, on top of that, we also heard earlier about the value of having ensemble forecasting. So having lots of forecasts, not just one, but lots of forecasts that take into account some of the uncertainties we have in the observed system. And you can do that using multiple models from multiple groups around the world as well. And that means that allows you to incorporate this uncertainty in the processes and how they're represented. And that allows us to build larger, more robust ensembles and to give us more reliable probabilities around some of the weather forecasting and climate projections work that we're doing. So it's really that international collaboration that allows that learnings across all the national borders.
Well, I certainly got the sense that the last 3 days you were geeking together very deeply, right, to enter into the deeper aspect of science. Faye, I mean, you're part of the Philippines government, right, in the observatory or not?
No, we are actually a private research institution with strong ties to the academe, but we also work with the national and local government in providing science advice. And if I may add to what Jason said, so the Philippines, we come from the global south, and as I mentioned, it's really valuable to have this high resolution information coming from multiple models, multiple scenarios, and that can be really computationally expensive. And also like data storage wise, that's a concern. So it's really hard for just one country to do this alone. And that's what made Cordex Southeast Asia a really nice collaboration, because we follow a task sharing basis of coordinating the experiments that we need to do. And so different countries will have to do these sets of experiments. And not just that, but we also share leadership. So for example, we've had projects together, and the leadership is actually changing from one country to the other to give opportunities for this country to take the lead. And furthermore, we also are very keen on building our capacity for the climate researchers and the students. So we have these workshops along with our projects, and these workshops are being done in different, we take turns in hosting these workshops so that it's not just us, but we can also invite local researchers to participate.
Well, I'm just wondering, and my colleagues also at HKUST and maybe other universities, because climate has become much more important, I mean, people are understanding, it really cuts across public and private sector and industry, commercial, non-commercial. are you seeing younger people, our students, going more deeply into these areas? Is it becoming more popular? Yes? 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 Good, good, because we do need young people to have the specialty knowledge. And perhaps I can then come to you, Director. Are you hiring some of these people? I mean, you know, I think what's interesting to me is I do know, I mean, you are my favorite department because I know the long-term 35 years, right, yes, of investments. And is it that most of your hirings are engineers, but are you now beginning to hire physicists and meteorologists and others? Of course, you can work with other government departments as well. Yes, sure. Maybe you can tell us a little bit about the journey.
Oh, sure.
Yes?
Sure. Thank you very much for this golden opportunity for me to share with you our journey. Our department, Drainage Services Department, have done in the past 35 years. Since our establishment in 1989, as I mentioned in my PowerPoint, that the government has since invested over 32 billion Hong Kong dollar in drainage improvement project. In early June this year, I have attended the Singapore International Water Week. In the opening speech by the speaker from the United Nations, she made a very good point and quote the finding of a study that she said every dollar we spend in drainage project or measures to enhance the resilience of our society, there will be a $50 saving as a result of the economic loss of the extreme weather event. So the money, I would say the money we spend is well spent. And I'm going to share with you more details about the project we have completed in the last 35 years, including 4 drainage tunnels with a total length over 21 kilometers, 5 underground stormwater storage tanks with total storage capacity about 250,000 cubic meters. And
how much is that? I mean, you all know, right? Underneath the Happy Valley race course, there's
yes,
a huge reservoir there,
yes,
right?
Yes. Yeah. Oh, for that one, the storage capacity is about 60,000. One very latest figure I have obtained from my team during the bad rainstorm warning signal hoist during this Tuesday. We have recorded storage volume of about 42,000 cubic meter in that tank with a capacity of 60,000. So you can see the effectiveness of our facility to protect our community, especially the area in Causeway Bay and Happy Valley and also Wan Chai. So maybe you can notice that not too many flooding cases happen in these areas. Of course, we have other storage tanks. Another one is in Kowloon side, and also 2 in the Kwun Tong area. So maybe I continue with the project we have completed. And currently, we have 15 drainage improvement projects which are under construction, including 9 new stormwater storage tanks with a total capacity of 32,000 cubic meters, which is a double of our existing capacity, which will be completed in phase by 2030. Maybe I take this opportunity to share with you more about the innovation technology application of our department. You have seen something I've mentioned in the PowerPoint about the robotic application. And actually, there's a very important system we have put in place for so many years. It's called the Hydrological Information System, HIS system. This is a real-time flood monitoring system, and our staff can access the departmental HIS system while mobile device to obtain real-time hydrological data, enabling monitoring around the clock, the river, water level, and also the road flooding situation. Over 300 water level sensors and rain gauge has been installed across various districts to collect real-time hydrological data of Hong Kong. including the rainfall intensity, water levels in rivers and coastal area. Since last year, we have also installed, as I mentioned, the reading line system. It is actually an innovative device invented by our mainland counterpart. And this is actually a breakthrough that I would say Hong Kong is now entering into a new era that we can be able to do real-time monitoring of flooding in our city. So that's all I want to share.
Okay, maybe well, this is good to transit to the two commercial side. I mean, the government spending, in a way, is the public sector contribution to extreme events where there's no damage. You're taking care of, in a way, the private sector, and here's a client, a happy client so far. So maybe you can share with us the kind of homework you've had to do, which you didn't have to do before. I think I get for example, with Clement, you're shared with us that the insurers are having to learn all this and having maybe a different view about what to do. And then for the clients, you too have had to learn, right, about the climate science, what it is, and how to prepare your plans. Maybe you can tell us, share something with us. Woody?
Sure. Yes, I think there's definitely a steep learning curve. I think that curve started for Link, I guess, immediately after Mankut. I think that was the wake-up call, I guess, for the property sector. But I think it's not just about us learning. You know, I'm from the sustainability team, but the key point is how we actually educate other teams into putting resilience into action. So how do we actually talk to our property management teams? How do we talk to our repairs and maintenance teams, our projects and engineering teams, to let them know what the biggest risks are, which are the buildings which are going to get flooded most easily, looking back at past records, and apply the climate projections to that. Yes, it's a big learning curve, but not just for one team, but across the whole company. So, you know, putting in since 2018, a lot of the rainwater pipes have been diverted away from within the property, putting in the flood barriers and all that. So yeah, definitely the learning curve is there, but it's also constant learning. You know, we're still learning a lot of new stuff, and that also comes in not just from the science side, but also from the district level. So we engage DSD from time to time to learn what they're doing in our area and how we can cooperate with their efforts. So that's also very important, I would say.
Well, we'll come back to the director later on about how specific you can go to a street, because that's what they want to know. But let's hear from Clement first.
So thanks, Professor Law. So I think I will just make it shortly. Like just now mentioned, a very important thing is both government and sort of private sectors. But as an industry, we're covering not just one happy client. We hope everyone is happy. So I think one of the things about the learning thing is actually the power of science is like, so now we will see that. We will see the infrastructure from the district, from the reservoirs helps. So that's what we now see it. But actually the power of data, basically I have to verify that. But to me, this is the first part because it's a hygiene, right? So verifying something that I expect to know as an underwriter, that's hygiene. So another thing that I mentioned about the blind spot. So I hope science can also help these things. I mean, the learning curve is actually we have to verify with the lost data versus things, and we will see what kind of determining factors. The key thing is more on the more predictive things. During break, one of the guests here, one of the participants here from the construction industry also talked to me, because for predictive thing, it's not about the built structures, also some ongoing structures and some of the things. So that's why, to me, as an industry, I think the learning curve is how to be verify our understanding, how we learn from those things, especially now the self-invited guests come so frequently, right? So it comes 7 days twice, right? So as long as you move it too fast, and also actually the impact, just now we also mentioned actually it's come up with a very short period of time with a very extensive rainfall quantum, right? Then how actually we respond to that? So I think that the learning curve is like this. So as an industry, that's why we need to work together. Just now mentioned about from no matter private sector or public, they have the sensor information, how we draw the causation. That is the learning things that hopefully will help. So this, a short answer to this, yeah.
Well, I'll come back to the director. This frequently uninvited guest, or undesired guest who shows up at inconvenient times. You know, people kind of want to know, can you predict, or to what extent can DSD do, because they want to know that street, right, in Wang Dai Xin, or some other street, because I think people in the insurance sector, in the district, your bosses maybe, right, and also people in the financial services sector always want to know about the risk. So how specific is your work today?
Okay, this is a very good and important question. I did make a note on this topic, so I'm very happy to share with you our ambition, the ambition of our department, how to achieve this. And maybe Clement is happy to know more about this from the insurance industry. I can tell you that this is exactly what DSD is trying to achieve. Two sequential processes are involved here, namely rainfall prediction and flood prediction. Let me go through them one by one. Technically speaking, the Hong Kong Observatory is capable of providing predicted rainfall data, but the major limitation is high degree of uncertainty in providing accurate prediction in advance, say more than 2 hours before arrival of the rainstorm. This creates great problems to the subsequent flood prediction process. Let me explain why. Traditionally, we use computerized hydraulic model to analyze rainfall data to assess the hydraulic performance of our drainage system and also the flood risk as a result, so as to ascertain the extent of flooding. Nowadays, computerized hydraulic models is so advanced that its simulation result can help predict flooding in district or even street level. The limitation of this kind of hydraulic model run required a long lead time, way longer than how advanced the Hong Kong O can produce their rainfall prediction at this stage. So to overcome this challenge, on Tuesday this week, my engineer already showcased a new computer system developed by our department called M-Cube. In a nutshell, we carry out hydraulic model runs for numerous scenarios using historic rainfall data of Hong Kong. This pre-run simulation result form a useful database for the department. When a rainstorm is approaching Hong Kong, what we need to do is to carry out a simple matching process between the real-time rainfall data from HKO and the scenario in our database with similar rainstorm characteristics, such as intensity, extent, path, and distribution. And hopefully, this can produce a decent flood prediction in a district or even street level. To achieve this, we are now in collaboration with the South China University of Technology to build a territory-wise computer model using XAI technology. The added benefit is that the XAI technology should be capable of filling the technology gap of rule-based model, which cannot simulate the effect of blockage of gullies and drainage index in the flood prediction process. This is one of the biggest challenge we have been facing in the past. So accurate and speedy prediction of flash flood due to rainfall is a long shot range, I would say. The target is out of range, and the chance of success really depends on many factors, such as accuracy of climate prediction, application of innovative technology, such as XAI for flood risk assessment, and wider use of real-time flood monitoring device. So With that being said, DSD is striving to advance our flood prediction capability to a high level. Thank you.
Right, well, it'll be a tremendous amount of work, and hopefully now that you have been so successful on Tuesday, that even though the financial secretary says he has limited money, that he'll make sure he gives you sufficient. Yes, yes. So we have maybe 15 minutes of time. May I invite some questions? Yes, please. A previous director of the Hong Kong Observatory.
With the drainage department being so successful, could the insurance industry consider lowering the premium? And is the industry thinking about region-dependent premium rates based on the efficiency of the DSD? I'm really worried about this because a lot of our young people will be buying properties. And if they buy the properties in the wrong place where you would be raising the premium, it would be terrible. So the key question is the industry considering region-dependent premium rates?
Okay, thank you. As burning as usual, huh? So as burning question as usual. So basically, first thing is, just now I typically mention about the availability. So first thing is, we don't have shortage, that's good. I think that's exactly the tied to back that learning curve thing. So just now I show on the screen, it's like a summary data. We don't have any location data, we don't know that. I think in the future, whether that will be some kind of dynamic pricing things happen, but I think we have to bear in mind that Hong Kong is still a very small city. So if you say you live just next of the street and then you just realize that your good friend, your neighbor on the next street, actually they have a 10% discount more. So that's a separate issue. So I think that's more on a business piece on to do. But back to the science things. That's why I think we need to work on that one. We have the lost data. Just now, Director also mentioned about there's a lot of things that have already done. So actually we have to find out whether actually there is some causation that affecting just on the region perspective. Just like, is it really Kowloon saying Kowloon City is actually better than Kai Tak or worse than Kai Tak? So that's a learning curve to have that kind of district things. But this is something that we want to find out the answer first. So in the future, definitely, as long as everything is become more and more transparent, I won't surprise that the citizens will ask for this. So, but at this stage, we don't have that capability yet. But I think that will be something that we will do. I think, so when we talk about climate things, so I seldom talk about really the discount at the account at certain point. I usually talk about a more long-term thing about the insurability. Because to me, climate change effect is more on the whether you get insurance or get the sufficient capacity of protection. So discount thing is more like an incentive to do protection thing, prevention. But I think that will be one possible future. Maybe I can get a little bit more. So in other countries, maybe they talk about some kind of parametric insurance. I think that is something, a jargon that people would talk about. But why I always emphasize that shortage. If something that actually you can't get the insurance, then parametric may help. Because now we got the insurance cover, you might concern a bit on the discount things, but if some of the city basically for natural catastrophe, basically that would be a separate cover. Or even that parametric thing is driven by the state government or those things, because it's a more social protection instead of just an insurance product. So yeah, that might happen, but I think that's also back to the point that just now Professor Law asked me about the learning curve. We need to learn about that thing. We have to find the insight from those things, any blind spot. And well, just like what we see in the, for the past few days, for past weeks, some of the traditional things we think will flood that the area that will be flooded is not flooded. There were some new spots, right? So this is what we need to learn. So it will be quite dynamic. Sorry, I hope I can answer this.
I think in the past we did have a discussion before about whether Hong Kong can have risk maps, right? Climate risk maps. And I wonder whether anyone would like to comment on this. I think CM, you talked about it before. And also, I guess to do these kinds of maps, we need more information working together and updating, right? You know, because climate is changing.
I think that's one of the contexts that today we talk about the resolution. So when we talk about district things, that means the resolution come up. So now the model, the price basically is quite homogeneous because actually the squares is too large, right? So that's one thing that actually I think this ties back to the discussion I think from a scientist this morning is about the resolution things. That's a collaborative effort. So both things, I think Professor Chen will talk about this for many times. So the resolution come up, then actually that will be come up. That will be step-by-step things,
right.
I would say.
Well, to be honest, I remember working with the insurance sector. We only really started to have this depth of discussion maybe about 2 to 3 years ago, right? So actually for us to have gone quite far, we have some what I call early adopters, right? Early movers. We have a long-standing, very strong DSD in Hong Kong. So I think those have allowed us, right, to kind of move ahead quite quickly. And then in joining the international knowledge that is out there, we've been able to go quite far. I see another hand there. Yes, the lady here.
Thank you so much, Christine. Yeah, hi, I'm Pretia from HSBC. Actually, I feel that the discussion is kind of narrowing down to one thing that is really about how can we foster more collaboration across sectors to build this, you know, either it's a climate risk map or a shared resource that can inform various stakeholders around how to do the modeling. So just as the morning speakers mentioned, the intensity of rarest event become even more intense, and then every time there's an event, it's sort of an opportunity to revalidate our assumptions correct, right? And then there's so many models out there, and everyone is trying to get hold of different models, but are we actually sharing the knowledge? What can be done to?
Well, maybe the Australian example is interesting, right? Maybe you know, you shared with us that you now have an agreed kind of model in Australia. Perhaps you'd like to comment on that point?
Well, there's agreed guidelines, which is not based on a single model. So there's still underpinning that many models that contribute to what ends up in the guidelines. Yeah. So, and the agreement is driven originally from the engineering and structure design side. And I think one of the reasons that this worked in Australia is that as a scientist, I stepped out of my comfort zone, which is, you know, playing around with the physics of the weather because it's super interesting. And I stepped into the hydrology and engineering world, and I went to the guidelines that they had written for their own industry. And I worked with them to adapt that to the changing climate. And I think trying to cross the boundaries like this is what really helps it to work.
Well, I do want to emphasize one point. You know, Pretia from HSBC, you've been kind of traveling with us, right, as a banker for the last 3 years or so. And we never used to have bankers come to this kind of environmental climate discussion, right? But people from financial services are actually now, we have many of you, right, coming to talk to us privately and you know, in open sessions like this. This thing about learning what to focus on. We had a meeting 2 weeks ago at HKUST with a contractor, engineering contracting company. And they asked us, and there was also someone they brought along who was working on risk and kind of insurance. And we actually invited someone from the financial services sector together so we could have this discussion like that. So for our climate science team, they need questions. Right? We were asked, for example, can you zone in onto a construction site? And can you do predictive stuff for us for the next, let's say 5 years, because that is the length of the project, right? So we had a terrific discussion. The answer is yes, right? And then we had a second question that I really thought was interesting. So a younger member of the construction companies said, well, actually, one day would be interested to know, you know, a building, what can you tell us about the 15th and the 16th floor? Would you be able to look at, you know, heat and whatnot, right? And is Jimmy Fung still here? Anyway, Jimmy was in that meeting, our modeler, and he kind of said, yeah, I think so, right? But I need some time. Now, what's interesting for me as a generalist is, you know, ask us questions, right? The climate modelers, and we need to go and learn from others, right? And engineers and whatnot, hydrologists and so on. But somehow, this wouldn't happen if we weren't collaborating. You know, so how is it that we can have more collaboration across discipline? It kind of makes us work much harder. And also, I think from a university, it requires us to have our students do more interesting work, right? That they have to be multidisciplined from the start. So I guess my question is, ask us difficult questions, which you are, right?
Okay.
Yeah, we have a collaboration with the insurance authority and the federation. So with insurance companies, you're asking us difficult questions because we wouldn't know how to ask ourselves as scientists.
Okay. Well, that's thanks for pointing me out. Okay. So I think the first thing is actually the collaboration means actually we will not work in silo because actually we have the different pieces of data based on things we should share, find a way that we can share. And I think one of the points that you point out that is very interesting is for scientists, ultimately you can calculate, but how fast can you calculate? So I think this is a collaborative effort because actually just like you mentioned about that meeting, I was not there, but at the sport, whether actually it's just that transparent that we can calculate everything is not, right? Scientists, you give them time, they can calculate. But from the key thing is the uninvited guests again come very fast, right? 2 days later, there might be the climate change. So I think particularly you mentioned about the construction, and it'll be the longest span, right? Just now Woody mentioned about the program review every year, so you can review every year. But as a construction, it happens, it will come up. So how can we protect that, and how can we stop those things repeatedly come up? I think that needs more things. But if you ask me, I think that's why sometimes we ask, well, what I'm focused is actually more on the predictive things. Because actually, these are the hardest things. First thing is science can give us more predictive things. Then we can think about how that predictive thing can help from a business impact perspective. So that's how I see it.
Right. Yeah. Well, we're coming to the magic hour for lunch. So I'd like to just invite each one of our panelists to maybe offer some quick perspective to end our tremendous 3 days. And then this morning, for our general audience. Perhaps we can start with you.
I would say nowadays, actually, many countries or cities are facing project financing problems. So recently, I've attended some international conference and a roundtable meeting with other cities around the world. One of the most talked topics about project financing. Where comes the money for the drainage infrastructure? So almost always in this international conference, the World Bank representative will be there to answer questions. So this is a common phenomenon. For Hong Kong, I would say Hong Kong is really lucky that we have made a lot of tremendous investment in the past decades, and it is paying off. You can see the resilience of Hong Kong. May not be the best over the world, but it's really good, I would say.
Faye.
If I may add also to what was mentioned a while ago, I think as scientists, we are also interested in the question of what are we calculating for. So it's really important that we have an understanding of the context of what the climate science is, what kind of information is needed. And I was also thinking that it's really important, and I appreciate that we have these kinds of forums that bring these different groups of people in the same room, because it's the only way that we could listen to each other. But from experience, it really takes time to build this trust and to also, get out of our silos. We have our own ways of doing things. We have our own language and jargon. So to come to understand each other. And I also was thinking about what you mentioned about the youth, the young scientists. I think we need to train more. The ratio of scientists to the end users, I think, is you have to address that challenge. And so I hope that the universities can also be able to train these young scientists and also expose them to interact with the other disciplines.
I've certainly seen in my time here and hearing today that there's been great investment in resilience in Hong Kong, and I think we saw that it's been quite successful. On Tuesday, the fact that the following day we went to the university and couldn't really tell that there had just been this massive event is really amazing. So the investment in resilience system-wide and at an asset level in Hong Kong is really good. Of course, investments in resilience, they show their value when you have extreme events. So I guess the good news is that they're going to show more value going forward. But of course, the bad news is that we know these extreme events are getting worse. So you have to keep the investment going. If you don't, you're going backwards.
Yeah, I totally agree with the earlier points. I think my first takeaway would be the financing part. We have to tie these projects to a financial value. It's not just governments who are facing issues with project financing. It's the same with asset management as well. And so we can't just come up to the projects and engineering team or financing teams or capital management teams and say, this is a risk assessment. This is the return period. We're screwed or something like that. They can't see the urgency behind that. But if we're able to say, this is your ROI from your capex, then it's easier for us to justify why we're building that resilience, or even a number similar to the Singapore International Water Week. How much cost are you avoiding for each dollar spent? These are the numbers that we need to be emphasizing when we're talking to these different stakeholders, I would say. The second part, I just have to emphasize again, the collaboration is important, really important. Temple Mall didn't get the flooding, this time round, but it did suffer some damage from water leakages on the second floor. You wouldn't expect that. The reason being, there was a burst pipe upstairs in the housing estate above Temple Mall, and therefore the water leaked and then it damaged our escalators. So how do we work with whoever is responsible up there with those pipes outside of our operational control to make sure that doesn't happen again? So that kind of community-wide resilience is really important.
You have the last word.
Yeah, okay, so thanks. I think just now I mentioned about the working not silo. I think that's key, but I think bring out a very, very good point is sometimes when the private sector or commercial sector work with the scientists, we have to change a little bit of our mindset. So basic climate change, we have to face, we have to work together. But every time as a private sector, we also ask about the return. Okay, so that's why we ask about the burning things, the deliverables, right? But sometimes I think for this topic about the climate change things, from a federation, we try to encourage our members company not just on looking at deliverables, because we have to learn from that. I think that's what I try to point out. Sometimes it is not that easy to work with universities sometimes, because we do need that deliverable to respond to other stakeholders. But I think from a science perspective, we want to learn together. So that's what I'm trying to bring in. Yeah.
Well, maybe I can just finalize with a few things that I've learned over the last few years. One thing is climate scientists are not all the same. Right? Climate scientists, there is this group here who create models. So it's like the cake maker, right? Other people use the cake or eat the cake, right? So you're a very special group of people, and we are looking forward to this particular group, right, to help us to do higher and higher resolution models. And also, I think, Faye, you talked about not, because the world's not flat, right? You know, particularly in cities, you have all kinds of morphology, you know, whether you have mountains and hills and whatnot, and we have plenty of that here, plus we have extremely dense and high-rise buildings. So the situation here may be quite different from other cities elsewhere, right? So we need, I think your reminder to us is we work internationally, of course, to exchange information and experience, but you do rely on your local experts to write models that are more suitable, right, for your particular area. So thank you very much, Faye, right? You're going to have to lead that team and keep going. So I think then we know, I assume this must be right, because you are the creator of the models, that higher and higher resolution, right? Taking the landscape and morphology into account, what you are able to do at the universities, which takes a long time and lots of computing power, lots of students and so on, actually can be used by others, actually more commercially. And I think, Clement, you were saying to us, you guys are a bit slow at the university. Well, that can't be helped because we're not commercial. And I think it's really important. And this is something that I get asked a lot. There are so many people out there that are selling commercial services on prediction. Why do you guys matter at the university? We matter because we are the mother lode. Only at the universities would we do crazy things, right? The specialists and so on would do crazy things to build models, right? So, and getting more students, young people interested to do that, working closely with government, right, at different levels. I think it's so important. And then now we're finally stretching to the industry that are saying, oh, actually, it does impact on our value, it impacts on our business generally, and this is a global thing. So therefore, we have to find the ways, the language, the time, the resources, actually to work together. So I'm so grateful that so many of you have come to listen to this, and hopefully, oh, there's a hand. Gosh, yes, last speaker.
Thank you very much for the presentations and discussions. I just like to raise one point. I think what we have discussed so far is missing something called prevention. And I think the general public and the government, even the officials or even the presidents of the US, they should be educated more widely. Because I think it's our responsibility to protect our planet. If you just keep doing models to fix the problem, it's not the solution. I think what we need to do is really, every one of us need to do something to stop this extreme weather from getting worse. That's my
Yes, well, we do know that doing models alone ain't gonna do anything, right? So the models have to be used. And I think the emphasis on spreading the message, education, collaboration is the way we want to go. And hopefully, for those of you who have some spare cash, do invest in the universities, right? Because as I said, this is the mother lode. From there, we share with the community. So maybe I can please thank the panel for their expertise, please. And let me hand over to Alexis Lau to close the morning.
Yeah, I actually want to have a comment, which actually there's a lot of question. I think today we talk about high resolution model. Low resolution model cannot give you the detail. We must use high resolution model to actually stimulate as well as give us those details. But the physical model by itself would not be able to do it fast enough for real-time prediction. But we already know with the physical model generating large amount of data, when it is not raining, when it is not having all these extreme events, we can create the database And then with AI, now we can actually build the link so that when actual event happening, through this AI lens, we can go much faster. And this is not just happening in the physical model. I think the director has already told us that with similar application, we can actually do the flood forecast, not at that time running the model, but again, running those models much higher resolution earlier, and then in real time we add an AI. So I think this is a very important learning, is that if we want to have high resolution information when we need it, we need to build modeling system that has that resolution with all the data there, with the structure. University, somehow we like to create a lot of things. We spend a lot of time running model many different times. And now I think here is a direction. We need to work together, get information together, and spend time to build this database ready. With the AI maturing, I can see that the combination of these two can give us real-time prediction or a few days projection of what is going to happen. And I think this is very important, because without this fine structure, not just in the atmospheric model, because we really need the drainage hydrology model to understand the impact, as well as, well, we spend a lot of time just put the building form in our model so that the wind goes the right way. Now we actually have to have the underground. I remember when I was young, I liked to play SimCity. We need to do SimCity in a much more realistic form so that we understand how the things are going. But the big question of real-time prediction, I think we are going to get there if we have this type of modeling ready, run enough scenario, add AI, and then do it. So I think this is actually a very positive outlook. I just want to answer the question. Well, if we have this type of thing, we can identify hotspots or locations that our current system may not be able to cover very well, and then we can think about how to work with it. So running model, identifying this, I think is important. So sorry for closing with such a long remark, but I really think that we are getting something we used to think very difficult. And thanks very much for staying all the time, and particularly thank our panelists, the two panel, and particularly for our visitor coming all the way. They originally come for 3 days. We pull them and say, okay, stay longer to give this talk. So let's give them a big hand. And also for everyone coming in. Okay, we will continue to have this type of series later. Next year, actually, I just want to give an early warning, is that we will have the CARE 2026 conference. The focus will be early warning system for climate hazard. Most likely will be in November next year. Well, looking forward to seeing you again. Yeah.